Okay, so once again, good day, everyone. So this time we're going to have a discussions about abstract data types or ADT. Now, so we will be able to understand the basic implementation of abstract data types in programming. So, abstract data types or ADTs are an essential concepts in computer science and IT that is used to define the behavior of data structure in a programming language. So, an ADT is a mathematical model for a collection of data values and the operations that can be performed on those values. So it is an abstract definitions that specify the behavior of data structure without specifying the details of its implementation. In general, there are three main components of an ADT: the data, the operations, and the actions. The data components defines the type of data the ADT represents, and operation define the functions that can be performed on the data. And the actions define the properties that this operation must satisfy. In addition to the three main components, there are also several types of ADTs, including sets, stacks, queues or keys, and trees. Each type of ADT has its own set of operations and actions that define its behavior. So, to fully understand ADTs, it is essential to have a solid foundation in programming and information technology educations. In-depth lecture on ADTs can cover topics such as fundamental concept of ADTs, the design and implementation of various types of ADTs, and the properties and complexities of ADTs, and the application of ADTs in the real-world problems. Some useful resources for learning more ADTs include online courses, of course, textbooks, and academic papers. It is also helpful to practice implementing ADTs in programming languages to develop deeper understanding of how they work in practice. Again, abstract data types have many applications in information technology and computer science, from data storage and retrieval to algorithm design and analysis. And some common applications ADTs include, number one, database management system. I think that you already finished with your information management. ADTs are used to represent data types and structures in a database management system. And this allows to efficient storage and retrieval of data and enables complex queries to be performed on the data. Number two, of course, is the graph algorithms. Graph algorithms often use ADTs such as priority queues and hash tables to efficiently search for and manipulate graph nodes and edges. Number three, compiler design. So when running your program, either C, Java, C++, C#, Ruby, JavaScripting, we need to have either compiler or interpreter. So in ADTs, compiler design used to represent abstract syntax trees and other intermediate representation of program in compilers. And this allows for efficient analysis and optimizations of code. Of course, these ADTs are also useful in artificial intelligence. Maybe you visited Jollibee's. They have an AI applications wherein the robot bring the food in your table. And artificial intelligence ADTs such as stacks, queues, and trees are used in search algorithms for AI applications such as path finding and decision making. And as what I have mentioned earlier about Jollibee AI or robot, that is a path finding applications of a search algorithm for artificial intelligence. Number five, of course, is the network protocol. ADTs or abstract data types are used to represent and manipulate network packets and headers in network protocols, such as the TCP/IP or the transfer communication protocol or the internet protocol. Okay? The other one is, or number 6, is the operating system. Maybe everybody are also aware about the use of, or an example of operating system like DOS, no? Linux, Windows, and others. No? ADTs such as keys or queues and semaphores are used in the design and implementation of operating system to manage processes, threads, and system resources. We need to take note that the operating system will be an intermediary between user and computer, because all the actions done or performed by the users must coordinate first to the operating system, then the operating system itself provide the actions taken by the users. So as I mentioned earlier, the operating system must be or the intermediary between users and computers. And the latest one, of course, in our industry is the data science and machine learning. ADTs are used to represent data structures such as matrices and vectors in data science and machine learning applications. And this allows to efficient manipulation and analysis of large data sets. We need to understand that ADTs are fundamental concept in computer science and IT and have numerous applications across many different fields. Understanding ADTs is essential for developing efficient algorithms in data structures, in software development, and for solving complex problems in various domains. As I mentioned earlier, abstract data types are commonly used in IT and ComSci. And some of the most common example, number 1 is stack. Now, a stack is a data structure that follows the last in, first out, or LIFO principle, where the last element that was added to the stack is the first one to be removed. Common operations on a stack include push. Let's say, for example, to add an element to the top of the stack, and pop. If we have push, we have pop. Pop is to remove the top element from the stack. Number 2 is the key or queue. A key is a data structure that follows the first in, first out principle, where the first element that was added to the key is the first one to be removed. Common operations on a key include in key to add an element to the back of the key, and dekey to remove the front element from the key. Let's say, for example, if we wanted to print, let's say, for example, 3 different files. If we first print the file about data structure, of course, the operating system communicate with our printer and print the first in documents. Let's say, for example, the second document that you print is about Pateros Technological College mission vision. So automatically the printer perform, or the operating system, of course, gives signal to the printer that this will be the second one, and the third, and so on and so forth. And that is key, the first in, first out principle. Number 3, of course, is the list. A list is a collection of elements where each element has a position in the collection. Common operations on a list include insert. When we say insert, to add an element at a specific position in the list. And list, of course. And number 2 is delete, to remove an element from the list. And the number 3 is the search, to find an element in the list. It means to say that list is most applicable with our database or database system or database management information system, or even in data warehousing, data warehouse technology, and so on. Number 4 will be the set. A set is a collection of unique elements where each element appears only once in the set. Common operations on a set include add. No? To add an element to the set, remove, to remove an element from the set, and intersection, to find the common element between two sets. I think you have in our statistics subject before, no? This is what we call union. Intersection, that is union. No? Then number 5 is a tree. No? Tree is a hierarchical data structure that consists of nodes connecting by edges. And each node can have 0 or more child nodes. And the common operations on a tree include traversal, which means when we say traversal is to visit all the nodes in the tree. Let's say, for example, you have you have a game, no? Let's say, for example, you are playing a game, and before you win, you need to visit all the areas, no, planted in this application. So that is traversal. You need to visit all the nodes in the tree before you end. Next is insert, to add a new node to the tree. And the last one, of course, is delete, to remove a node from the tree. Okay? Actually, I'll just want to show you an example of a stack, no? A sample code. Now, maybe for those who don't have any background in programming, it's not easy for you to understand this one. So I have an example here about the stack, no? And this is just only a simple stack implementation in Java using array. Okay, so as you can see here, we are using, of course, the most commonly used, the public class. No, stack will be our variable. We are using private in top and data. And as you can see here, this one is represent an array, right? So we have an inside, then top is equal to -1. It means to say that this will be a shortcut or concatenated, because it must be top. It must be written like this. Top is equal to top -1. But we could rewrite this one into this one. And that is what we call concatenation. Na? Instead of writing this one, we are allowed to apply or to use this one. Same output, same results. Na? Even we want to run the program, it is still running and with the same output. No, that is concatenation. But why do we need to include once again the top if we could able to concatenate the top? It's the same. We shorten the codes. No, we listen the use of our memory. No, and we listen the time of typing the another variables. No, then data is equal to the new in size. No, then public void, as what I mentioned, in stack we are using we need to use the push. No, and this a conditional. No, then we wanted to print, no, the stack is full. System that out that print line, it means to say to the next line, no, then return value data. This is an increment, no, increment the value, then public in pub1. This time we have some conditional statement here and using some empty for the public boolean. So that's why, as I mentioned, if you have an idea already about Java programming, no, it's easy for you to understand data structure. So as I was read, no, your chat, this will be your first time. So I will encourage you, no, to watch more videos about programming 1 and programming 2, or from the introduction to intermediate programming, no, using Java or C or C++. Actually, all programming language has their own functions, but when it comes to codes, no, it's almost the same concept, same logic formulations. Now, and this implementation uses an array to store the stack data with a top variable to keep track on the top element of the track. So the push method adds an element to the top of the stack while the pop method removes and returns the top element. No? And this and the SMT, again, this is what we call reserve word, right? This reserve word and is full reserve word methods check whether the stack is empty or full, respectively. And the pick method or the pick reserve word method, no, returns the top element without removing it from the stack. Another example for key naman. So this will be a simple key implementation of Java using an array at the same time. No, so as you can see here, we are using key as our class name. No, we use front, rear as our variable, and for our array we use int data. Okay, so we use key, no, in size. Then instead of front is equal to front minus 1, we rewrite, we concatenate, no, front is equal minus 1. Rear is equal to rear minus 1. We concatenate to rear is equal to 1. Rear is equal to equal minus 1. And data is the new and size. For in key, no, we have of course a decision here, no, if else statement, actually just only an if statement for is full the key, no, at the same time, and the boolean yung SMT natin to return from -0. Okay, then afterward, no, this implementation uses an array to store the key data with front and rear variables. So to keep track to the front and rear elements of the key respectively, the in key method adds an element to the rear of the key, and while the dkey method removes and returns the front element. Same functions of the SMT is full and pick for this example. Okay, another example is the list. No, here is the simple linked list implemented in Java. So public class list node, no, we use val as our integer variable. No, list node was declared as our class name, so therefore this is a class name index. Then of course as what we have here, the int val, no. Then this dot val is equal to val. Then linked list of course. No, then add int val from list node new node is equal to list node val. And so it's just only a simple program, no, applying the list in an array. No, so therefore, sorry. So therefore, it means say that the implementation uses a list node class to represent its node in the linked list with a val field to store the value of the node as well as next pointer to link to the next node in the list. So the linked list class contain a head pointer to the first node in the list, and it includes methods to add and remove elements as well as print the contents of the list. So the add command method or the add method adds a new node to the end of the list, while the remove method remove the first occurrence of a node with the specified value, and the print method simply prints the contents of the list. Okay, I just want to show you an example again of a set naman this time. Sample of a set. This will be the simple set, no, set implementation in Java using hash set. So how do you call this one? Import java.util-hash set. This will be our import java.util.set. This will be standard as what? For those already finished programming 1 and 2. This will be our libraries. Okay? Then we use mySet as our class. No? For private, we use set as integer, and for public is mySet. we use Boolean, no, to return the set of value. And of course, int value, Boolean contains for the set value, return set value. For the remove, we use set that remove, no, still integer value at the same time. Then public int size to return the set that size. For SMT, we use, of course, Boolean, no, for if we wanted to print out, no, this value, no, this variables or this alphanumeric value, no, int value, then set, then plus for the system that out that print, no. Same with printf, no, in our C language programming. Okay, another example for this, no, using, let's say, for example, this one, no, we have hash set the fruits that are this apple, banana, orange, and so on and so forth. So system that out that print line with ln, no, so it prints banana, orange, and apple. So if we use this one, no, then we could able to find out or set contains apple or set does not contain apple for our conditions, no. This one uses if else statement, no, because as you can see here, if statement is applicable in all types of programming, same concepts, no, same syntax, no, for if else statement with other programming languages. And if we wanted to print, so this it will display orange and apple. For iterating over sets, no, for a string, no, so this one. Okay, so right now, based on the given example, actually, we create a hash set object which elements the set interface and add some elements to it. We then print out the contents of the set, which shows that duplicate elements are not allowed. And we also demonstrate how to check if a set contains an element and remove an element from the set, iterate over the set using for each loop, no, a while ago. So this one, I just want to show you an example of a binary tree in Java, which is also under, okay, our discussion of ADT. So this time, as you can see here, we use a public class tree node, no. So we use val as our variable, and we use int as our data types. Now we have 3 node left and 3 node right. So we use this, no, as a command, no, same for the public class binary tree. Excuse me. Of course, this root null value, no, and we use also insert integer as val, no, as our integer as our data types, then val is our as we declared actually at the top, no, we use the data type int and the variable val, no. So this time we use a comparative, no, that is a comparative operator, no, equal, that is a comparative operator, no, for the if statement alone. Okay, then we use key, no. This time we are using a looping statement, which is while, no, while statement rather, no. Then within the center of our while applications or while looping statement, we declared actually an if else if statement, no, and that's it for this code. Okay, it's just only a simple example of a what we call binary tree in Java. So it means to say that in that given scenario or program, we could able to implement uses a key to traverse the tree and insert new nodes as children of the first available parent node with an empty child slot. It is also includes a tree node class that contain a val field to store the value of the node as well as left and right child nodes. Actually, there are just a few examples of the many ADTs that are used in IT and computer science. So by understanding the properties and behavior of these ADTs, programmers can design and implement efficient algorithms and data structure for a wide variety of applications. So I think that's it for topic number 2. But I just want to share again a video presentation, a continuation of what I have played earlier, for you or to deepen your understanding of the data types versus the abstract data types. Okay? Because maybe you were asking, I just want more about these discussions because maybe sabi nga nung isa kanina, my God, na-starstruck ako, no? But again, as I mentioned, it's too hard for those students who doesn't have an idea of a Java programming prior to this data structure and algorithm. Very challenging to you. No, you need to have an additional, I think, reading, and watching videos related to Java up to the intermediate one. But of course, anything we wanted to, we could able to attain it because we want, okay?
Data structures, we first have to understand the difference between data types and abstract data types. So let's get started. What is a data type? We have already discussed what a data type is in our C programming lectures, but let's discuss it one more time because there are certain points which I haven't discussed there. There are two important things that I haven't told you about data types, although there is one point which is already clear, but there is one more important point which I haven't told about data types. First is it defines a certain domain of values. We already know that a data type defines a certain domain of values, right? But there is one more important point which says that it defines operations allowed on those values. So not only it is defining certain domain of values, but it also defines what operations are allowed on those values. For example, we can think of integer type. Here we can take only integer values. We already know that integer allows only integer values, right? But the operations allowed are addition, subtraction, multiplication, bitwise operations, etc. We can perform almost every operation with integer type. For the sake of understanding, let's take another type, that is float type. It takes only floating point values. We already know that the domain of values allowed in the case of float type are only floating point values. But the operations which we can perform on float types are addition, subtraction, multiplication, division, but we cannot perform bitwise and mod operations on them. This should be well noted. So it is clearly understandable that a data type not only defines a certain domain of values, but it also defines operations allowed on those values, right? Now, let's discuss what is a user-defined data type. Before moving on to abstract data types, we should understand what is a user-defined data type. In contrast to primitive data types, there is a concept of user-defined data types. We already know primitive data types like integer, character, float, right? But there is a concept of user-defined data type which we should also know. The operations and values of user-defined data types are not specified in the language itself, but is specified by the user. Here the user is defining the operations as well as the values. It is not predefined in the language itself. Okay, now here are the examples: structure, union, and enumeration, which we have already discussed. By using structures, we are defining our own type by combining other data types. By using structures, we are defining our own type by combining other primitive types. For example, here in this case, we have combined these two integers to form a new type, that is point. So it's a user-defined data type. This is our understanding about user-defined data types. Now let's try to understand what are abstract data types. ADTs or abstract data types are like user-defined data types which defines operations on values using functions without specifying what is there inside the function and how the operations are performed. First of all, we are defining operations, that is true, but we are defining operations on values, that is also true, using functions. It should be well noted that we are defining operations using functions without specifying what is there inside the function. We are not specifying anything inside what is there inside the function, okay, and how the operations are performed. Let's take an example of a stack ADT. A stack consists of elements of same type arranged in a sequential order. So what type of elements are allowed in a stack? the elements of same type. And that too, they are arranged in the sequential order. We already know that, right? Now the operations allowed on them could be initialize. We can define an initialize function, which initializes the stack to be empty actually. We can perform a push operation, that is insert an element into the stack. We can perform pop operation, that is delete an element from the stack. We can check is stack empty, or we can check is stack full. So these are the operations which we can define and we can perform on stack. These are functions, as you can see. Here we are specifying functions, but we are not saying anything how they can be implemented. We are just specifying them. That is called abstract data type. We know that what type of elements are allowed, and we also know that what operations we can perform, but we don't know what is there inside. Okay. Think of ADT as a black box which hides the inner structure and design of the data type from the user. We can think of it like it hides all the implementation details from us. This is very important, which we will understand later. There are multiple ways to implement an ADT. Let me tell you, this is very important. There are multiple ways to implement an ADT. For example, a stack ADT can be implemented using arrays or linked lists. It should be well noted that stack itself is a data structure. We can implement this data structure using other data structures like arrays or linked lists. Okay, so a stack ADT, which we know is right now a skeleton, can be implemented using arrays or linked lists. Now the question that immediately arises, that why do we even need ADTs? Why do we need skeletons? Why can't we simply implement things, display it to the user? Why ADT? Before moving further, we should understand some terminology. The program which uses data structure is called a client program. You should note this very clearly, that the program which uses data structure is called a client program. It has access to the ADT, that is the interface, nothing else, just abstract. And the program which implements the data structure is called implementation. So we have two programs. One is client program, the other one is implementation. Implementation is the one which implements the data structure, and the client program is the one which just uses the interface, that is the outside details, nothing inside. Okay. Now let's discuss the advantage. Let's say if someone wants to use the stack in the program, then he can simply use push and pop operations without knowing its implementation. A user doesn't have to worry about how the operations are performed. Okay. If someone wants to use the stack program, we know that program which uses the data structure is called the client program. It has access to the interface only and nothing inside. So he can simply use push and pop operations without knowing its implementation. Apart from this, if in future the implementation of stack is changed from array to linked list, let's say previously the stack was implemented using arrays, right? But now let's say it is changed to linked list, then the client program will work in the same way without being affected. There is nothing to discuss with client program. Client program has nothing to do with it. It can simply use the interface without knowing what is going inside. So if the implementation is changed from array to linked list, nothing will be affected in the client program. This is one of the biggest advantages of using abstract data types. Now it should be clear that why we are using it. Because with the help of abstract data types, we are actually separating the two worlds. We are just providing the user an interface. The rest of the details, the implementation part, is done in the backend. User doesn't have to worry about it. The implementation can go on without affecting the client program. That is why the need of abstract data type came. Now here's the conclusion of this lecture. Abstract data type provides abstraction. We should understand this, that abstract data type provides abstraction, which means hiding details from the user, and it is very important because user doesn't bother about that how that particular thing is implemented. He just have to use that thing. That's it. So this separation is required. Abstract data type is, that's why, very useful concept. Okay friends, this is it for now.
Okay, as what our videos mentioned, no? uh, the implementation of the ADTs, no? It could be for design and implement efficient algorithm in this data structure for a wide variety of applications. No? because again, ADT, as what our presentation mentioned, must be used, no, for built-in data types, no, that are provided, no, and data types such as int, no, float, double, long, no, you're familiar, no, and others are considered to be in the built data types, and we can perform basic operations with them and others, no, and of course, we are all familiar with addition, subtraction, division, and multiplication, and others. And we might be a situation when we need operations for our user-defined data type, which have to be defined. And these operations can be defined only as when we require them. So, in order to simplify the process of solving problems, we can create data structures along with their operations, and such data structures are not inbuilt or are known as abstract data type. Then, abstract data types is a type or class of objects whose behavior is defined by a set of values and a set of operations. And the definition of ADT only mentions what operations are to be performed, but not how these operations will be implemented. It does not specify how data will be organized in memory and what algorithms will be used for implementing the operation. It is called abstract because it gives an implementation independent view. And the process of providing only the essentials and hiding the details is known as abstraction, as our video mentions. No? So the user of data type does not need to know how the data type is implemented. Let's say, for example, no, we have been using primitive values like int. Tapos sinabi natin primitive, int, float, char, data types only, with the knowledge that this data type can operate and be performed on without any idea of how they are implemented. So a user only needs to know what a data type can do, but not how it will be implemented. Think of ADT as a black box which hides the inner structures and design of the data type. Okay, so actually, so the for the list ADT as what we discussed earlier, the data is generally stored in a key sequence in the list which has a head structure consisting of account, pointers, and address of compare functions needed to compare the data in the list. So the data node contains the pointer to a data structure and self-referential pointer which points to the next node in the list. No? So the list ADT function is, of course, the available is get. No? We say get, opening close parenthesis, return an element from the list of any given position. We have insert an element at any point of the list. We have remove, of course, a while ago, we demonstrated some example of remove. Remove the first occurrence of any element from a non-empty list. And remove the element at a specified locations from a non-empty list. We have replace, replace an element of at any position by another element. And size, return the number of elements in the list. We have is empty, no, return true if the list is empty, otherwise return false. And is full, return true if the list is full, otherwise return false. No? Under stack, no, we have in stack ADT, no, implementation, instead of data being stored in each node, the pointer to data is stored. So the program allocates memory for the data in address is passed to the stack ADT. So the head node and the data nodes are encapsulated in the ADT. The calling functions can only see the pointer to the stack. And the stack head structure also contains a pointer to top and count of counter of entries currently in stack. Ano yung mga available natin? Siyempre yung push. No? Push, insert an element at one end of the stack called top. We have pop, remove and return the element at the top to the stack if it is not empty. We have earlier pick, return the element at the top of the stack without removing it if the stack is not empty. We also use size, size, return the number of elements in the stack. We have is empty, return the true if the statement is empty, otherwise return false. Is full, return the true if the stack is full, otherwise return false. We have also key ADT, I already discussed the key ADT earlier. So the key ADT, okay. So the key ADT or the key ADT or abstract data types follows the basic design of the stack abstract data type. Each node contains a void pointer to the data and the link pointer to the next element in the key. So the program responsibility is to allocate memory for storing the data. A while ago, I showed an example of a program using in key and the key. Now, in key, it means to say that we insert an element at the end of the key. The key, remove and return the first element of the key if the key is not empty. We use also size, return the number of elements in the key. Is empty, return the true if the key is empty, otherwise return false. Is full, return the true if the key is full, and otherwise return a false. So some features of ADT, abstract data types are a way of encapsulating data and operations on the data into a single unit. And some of the key features of ADTs include abstraction. Okay? Abstraction in a sense that the user does not need to know the implementation of the data structure, only essentials are provided. We need to have a better conceptualization because ADT gives us a better conceptualization of the real world. Robust, the program is robust and has the ability to catch errors. I think you are familiar with the command, or with an application of Java that try catch. Another is encapsulations. ADTs are hide the internal details of the data and provides a public interface for user to interact with the data. And this allows for easier maintenance and modifications of the data structure. Data abstraction, of course, ADTs provide a level of abstractions from the implementation details of the data. Users only need to know the operations that can be performed on the data, not how those operations are implemented, as what I mentioned earlier. Data structure interdependence. ADTs can be implemented using different data structures, such as arrays or linked lists, without affecting the functionality of the ADT. We are also what we call information hiding, because ADTs can protect the integrity of the data from allowing access only to unauthorized users and operations. This helps prevent errors and misuse of the data. And the last one is the modularity. ADTs can be combined with other ADTs to form larger, more complex data structures. And this allows to greater flexibility and modularity in programming. And of course, to summarize, ADTs provide a powerful tool for organizing and manipulating data in structured and efficient manner. I'll just want to reiterate, class, abstract data types have several advantages and disadvantages that should be considered when deciding to use them in software development. To cite a few, no, for the advantages of using ADTs. In encapsulation, ADTs provide a way to encapsulate data and operations into a single unit, making it easier to manage and modify a data structure. For abstraction, ADTs allowed user to work with data structures without having to know the implementation details, which can simplify programming and reduce errors. Another advantages is data structure independence, because ADTs can be implemented using different data structures, which can make it easier to adapt to changing needs and requirements. Another advantages is information hiding. No, ADTs can protect, no, the data, the integrity of data by controlling access and preventing unauthorized modifications. And of course, modularity. Now, ADTs can be combined with other ADTs to form more complex data structures, which can increase flexibility and modularity in programming. If we have pros, or if we have advantages or pros, we have disadvantages or cons. Cons number one, overhead. Implementing ADTs can add overhead in terms of memory and processing, which can affect performance. Number two, complexity. We need to take note that ADTs can be complex to implement, especially for large and complex data structure. Number three, learning curve. Because using ADTs requires knowledge of their implementation and usage, which can take time and effort to learn. Another cons or disadvantages is limited flexibility, because some ADTs may be limited in their functionality or may not be suitable for all types of data structures. And another concern or disadvantages is the cost, because if we implemented ADTs, it requires additional resources and investment, and which can increase the cost of your software development. Okay, so the advantages of ADTs often outweigh the disadvantages, and they are widely used in software development to manage and manipulate data in a structured and efficient way. However, it is important to consider the specific needs and requirements of a project when deciding whether to use ADTs. So from these discussions, we can clearly see that the definitions do not specify how these ADTs will be represented and how the operations will be carried out. There can be different ways to implement an ADT. Let's say, for example, the list ADT can be implemented using arrays or singly linked list or doubly linked list. Similarly, stack ADT and key ADT can be implemented using arrays or linked lists. Okay, so I think that's it for our lesson number 2.